Okay, day two, we're going to do series and partial sums. This is where we're going to take our sequences and we're going to add them together. Okay, so this is called the Gaussian example. A German mathematician, last name Gauss, uh, came up with this one a long time ago. Find some of the first 100 numbers. Obviously, you could count them up, but if you take a look at this, that's 101, and that is 101, and that is 101, and you will get right into the middle of 50 plus 51. So really what you have is 50 times, because 1 through 50 is all paired with the other ones, you're multiplying together 101, which is 5,050. If you break this down further, it takes two values to add them together. There was 100 total values, and to get the 50, we split it in half. And where did we get our values? Assuming we have an arithmetic sequence, which we do, you take the first one plus the last one. So it was 1 plus 100, which is really breaks it down to n over 2 times the first plus the last. And that's going to be our arithmetic sum formula. There it is. Sum of the first n terms is equal to the number of terms divided by 2 times the first plus the last. That's what we're looking for. A partial sum means we're going to have some infinite sums in the next lesson. But now we're talking about partial. Obviously, if you're arithmetic and you're going up, you're going to go up forever. So you can't have an infinite sum. We got to find what value 80 is. So the first thing I need to do is figure out that A1 is 1 and the common difference is 4. And the nth term is 80. So I will use, so you're always going to use the other form too, a1 plus n minus 1 times d. Some of you probably can figure this one out. Some of these you can figure out, but we got to know the process because it's not always easy. 80 equals the first term plus the number of terms minus 1 times the common difference. Subtract the 80 over 72 equals n minus 1 times 4. For these ones, I don't distribute the 4 in. I take 72 divided by 4 and get 18 is equal to n minus 1, so n is 19. Okay, so this is the 19th term, all right, which I'm sure some of you probably thought it was the 20th term, so you got to be a little bit careful there. So we're really finding this, whoa, what happened there? What is going on? The sum of the first 19 terms is equal to the number of terms divided by 2 times the first plus the last. Okay. And now we can just plug that into our calculator, and we get 836, I believe, is what it comes out to. And there you go. Pretty fast way to find the sum of a arithmetic sequence. Here we go again. You got to find 68. So I got A1 and I got common difference. This is A1. Common difference is 7. And I got AN is over there. So the first thing I got to do is find the nth term. 68 is equal to the first term plus n minus 1 times the common difference is 7. Subtract 5. 63 equals n minus 1 times 7. Divide by 7. I get 9er. If n minus 1 is 9, then n is 10. So now you can find the sum of the first 10 terms is equal to the number of terms divided by 2 times the first plus the last. Because and another way to look at it is you're averaging it. You're averaging the first and the last, and then it's 10 times. I've seen it done that way as well. So this is really 5 times 73. If I did my math right, 365 days in a year. Beautiful. Some of those first 10 terms. Find the first 3 terms. So now notice we're given. So if we're looking at Sn equals n over 2 times the first plus the last. So they've given me my sum. That's going to go there. They've given me A1. They've given me the nth term. And I want to know, what is this n? So 129 equals n over 2 times the first plus the last. Pro tip, no one likes fractions. How do you clear a fraction? Multiply by 2. That would be 260, so it must be 258 equals n times 29 plus 14 is, what, 43? So I'm going to divide by 43. It goes pretty quick if you, so 258 divided by 43, 6. This is the sum of 6 terms. Got me to 129. Oh, geez, there was 6 total terms, which means actually now I gotta find, shoot, I didn't finish the problem. I gotta find the common difference. So 29 is the first term plus n minus 1 times the common difference. So now I got to find the common difference too. So that's 15 equals 5 times d divided by 5 divided by 5. D is 3. 6, 9, 12. Da-da, da-da, da-da. Same thing here. They give me the sum. I'm looking for the number of terms. 11 plus 31. So I got to multiply by 2. 210 n times 42, divide by 42, that's got to be 5, huh? And then we have to go to the nth term is equal to the number of terms divided by 2 times the first. Or, nah, now we're doing something different, aren't we? That's not right. What am I doing? Unbelievable. Just mailing it in here. Oh, no, I erased it all. I got n was 5. Okay, let's go back to that. So I got the nth term is equal to the first term plus n minus 1 times the common difference minus that for d. D is 5. 11, 16, 21, and so on and so forth. Okay, geometric. This is a big old formula, huh? A couple common mistakes here. If you, depending on how you're doing the problem, this has got to be in parentheses as well. And this n is on the r. It's not on the outside of the parentheses. That is very, very, very important. So what I need here, I want the sum of the 8 terms. So I need the first term is 3. I need the common ratio is 15 divided by 3. And I need the number of terms is 8. That's all I need for this. I actually need less things. First term is 3. 1 minus the common ratio raised to the 8th, all divided by 1 minus the common ratio. I need to put it in my calculator just like that. My calculator will make mistakes, but my calculator does not get graded on the test, okay? So that is very important. So when I divide, you can either divide by -4, if you know that, 1 minus 5 is -4, or you can type in 1 minus 5. But if you type in 1 minus 5 on the bottom, it's got to be in parentheses, okay? So these are exponential equations, so they go up very quickly. So I got 292,968, which shouldn't surprise you because this is times 5 times 5 times 5, and we would continue on and we get a very large number. So please make sure that you put this into your calculator correctly. Find A1. I'm looking for A1. They've given me the sum. They've given me the value of n. They've given me the r. So now I got to work backwards, okay? So I'm going to go with 765 equals A1, which is what we're searching for. 1 minus 2 to the 8th. 2 to the 8th, I am. 1 minus 2, okay? If I was doing this problem, and I guess I am, this is -1, so I would multiply both sides by -1, okay? That clears that denominator. -765 equals A1 times 1 minus 2 to the 8th. And then I would just take my negative 765 and divide by, in parentheses, you have to put it in parentheses, or the calculator makes a mistake, and the calculator does not get graded. And I get A1 when I divide by this. So exactly what I put in my calculator is right here. That's what I typed in, just how it looks. A1 is 3. So now that I have A1 is 3, I could find some other stuff if I wanted to. Again, find A1, 364 equals A1 times 1 minus R to the 6th over 1 minus R. This is negative 2. You with me on that? I'm going to multiply by negative 2. Negative 2 times 364 is negative 728 equals A1 times this big nasty. Whoops, that's a 3. Sorry. Divide by 1 minus 3 to the 6th. Divide by 1 minus 3 to the 6th. Negative 728 divided by, in parentheses, 1 minus 3 to the 6th. On the old calculator. I got 1. Are you kidding me right now? The first term was 1, so this would have gone 1 times 3 times 3 times 3 times 3 times 3 times 3 da 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 da. That's probably it right there. Hey, there's that's 6 terms right there. Those add up to 364. That makes sense. That's it. Do your homework. Be good people.